In 2025, humanity is not just looking up at the sky, we are taking one step at a time into space. Artificial intelligence is searching for mysterious caves on the moon. NASA is planning to build a nuclear reactor in the realm of zero gravity. And billionaires, even the elderly, are flying into space as part of extravagant tours. Behind the sensational headlines lies a fierce race between world powers, a future of commercialized space, and a haunting question: who will be the next to rule the skies? Join us as we delve into the full picture of space exploration in 2025, where technology, politics, ambition, and human intellect are shaping the future of an entire civilization. 1. Artificial intelligence and the revolution in space exploration. In early August 2025, researchers from various space agencies and international academic institutions announced a surprising discovery. They had identified a series of lunar pits on the moon's surface thanks to the application of artificial intelligence. This is a revolutionary achievement because, in the past, locating such terrain features required manually analyzing hundreds of thousands of satellite images, a process that could take years. With image processing and deep learning capabilities, AI shortened that timeline to just a few weeks or even days. But the most remarkable aspect isn't just speed. More importantly, AI has opened a new direction: automated space exploration. These lunar pits may lead to underground cave systems beneath the moon's surface, areas with stable temperatures and natural protection against solar radiation and meteorite impacts. Such locations could be the key to establishing the first human base on the moon in the near future. In this way, AI is no longer just a support tool, but has become a powerful teammate to explorers on the journey to expand humanity's frontiers. 2. Nuclear reactor on the moon, the race for extraterrestrial energy power. In a bold move, NASA has announced that it is pushing forward with plans to build a 100-kilowatt nuclear reactor on the surface of the moon, with completion targeted before 2030. This is one of the most critical projects under the United States' new space strategy. In theory, solar panels could supply power to equipment or lunar bases, but the moon's day-night cycle lasts up to 14 Earth days, making solar power unreliable. A mini-nuclear reactor would provide stable, continuous, and sustainable energy to support human life, oxygen and water production, and environmental control systems. However, beyond the technical aspects, this is also a strategic blow in the realm of space geopolitics. China is rapidly developing a similar space nuclear program, while Russia, despite internal challenges, continues to exert significant influence through global space cooperation initiatives. The extraterrestrial energy race is not just about survival. It's about asserting dominance, controlling territories, resources, and most importantly, laying the foundation for future off-world ecosystems. Whoever controls the energy, controls space. 3. Cooperation or competition, the U.S.-Russia relationship on the International Space Station. After years of disruption due to geopolitical tensions and conflicts, the heads of NASA and Roscosmos, Russia's space agency, held their first official meeting since 2018 at the Kennedy Space Center in Florida. The focus of the meeting was on maintaining and operating the International Space Station, ISS, through 2030, a critical milestone before many nations plan to withdraw and launch their own space stations. While the U.S. is heavily investing in commercial space station projects, the ISS remains the only existing platform for long-term international cooperation in space. Meanwhile, Russia continues to play a vital technical role in navigation and maintaining the ISS's propulsion systems. This cooperation between two former Cold War adversaries now stands at a delicate balance between technical necessity and strategic interests. The meeting sends a powerful message. Even as the world on Earth grows more divided, space still demands collaboration, at least until each nation can become fully space self-reliant. 4. Ordinary people in space. The expansion of commercial space travel in August 2025. Blue Origin, Jeff Bezos' space company, successfully completed its 14th crewed flight using the New Shepard spacecraft, carrying 6 passengers to the edge of space. Among them were crypto-billionaire Justin Sun and Mr. Arvinder Singh Bahal, an 80-year-old entrepreneur from India. This was not a scientific mission, but it marked an important symbol. Space is no longer the exclusive domain of astronauts or world powers. It is becoming a new frontier for tourism, personal experience, and even fame. 50 years ago, only a few dozen people had traveled beyond Earth. Today, that number has reached into the thousands. The commercialization of space not only reduces technology costs through large-scale production, but also brings the public closer to once unimaginable dreams. Of course, at present, the cost of a spaceflight still ranges from $200,000 to several $1 million per person, far beyond the reach of most. However, according to the logic of technological development, as the market expands and competition increases, prices will gradually decrease. Within the next 20 years, spaceflight may well become a premium form of tourism, much like how commercial air travel was once reserved only for the ultra-wealthy. 5. Quiet but strategic scientific missions. Alongside symbolic or commercial activities, important scientific missions continue quietly, laying the groundwork for major breakthroughs in the future. A prominent example is NASA's Europa Clipper mission, scheduled to launch in late 2025 to explore Europa, one of Jupiter's moons. Europa is one of the rare places in the solar system where scientists believe life could potentially exist, thanks to a subsurface ocean beneath its thick icy crust. Europa Clipper will use ice-penetrating radar to listen beneath the surface, searching for signs of liquid water, heat, and essential chemicals, key ingredients for life. At the same time, China is demonstrating its long-term space ambitions with the Tianwen 2 mission, which aims to collect samples from the near-Earth asteroid Kamo'olua, and then continue its journey to Comet 311P. This is an extremely ambitious strategy, combining several advanced technologies, precise navigation, sample collection, storage, and safe return to Earth. If successful, Tianwen 2 will not only elevate China's scientific standing, but also serve as a stepping stone toward extraterrestrial resource extraction, an industry predicted to be worth trillions of dollars in the future. When space is no longer distant. The year 2025 marks a clear turning point in humanity's journey of space exploration. From mapping lunar terrain, to a nuclear reactor being prepared for construction on the moon. From the growing number of civilian astronauts to the complex cooperate and compete dynamics among superpowers, everything signals that space is no longer science fiction, but a reality unfolding day by day. The biggest shift is not in technology, but in mindset. Space is no longer reserved for governments or militaries. It is becoming a place to live, work, do business, and perhaps even to date, vacation, or marry in the near future. The modern space race is a race of vision, innovation, and power. In this race, every technological breakthrough brings opportunity, but also raises challenges in ethics, law, and the fair distribution of space resources. Humanity is entering a phase where presence beyond Earth is no longer a question of if, but of how, when, and by whom. And in that moment, the question for all of us is not only, how will we conquer space? But also, who will we become once we're out there? If you want to join us on this journey, don't forget to subscribe, turn on the notification bell, and share this video so we can explore space together. Not just with our eyes, but with our minds and hearts.